Welcome to the DIY Honda Garage channel. DTC P2127 is a diagnostic trouble code that indicates a low voltage condition in the APP, Accelerator Pedal Position Sensor B circuit, specifically the TP Throttle Position Sensor E. This code is part of the PGM-FI programmed fuel injection system in the Honda Civic models ranging from 2016 to 2021. When the engine control module, ECM, detects that the voltage from APP sensor B is below the expected threshold, it triggers this code. The APP sensor plays a crucial role in determining how much throttle is applied based on the driver's input. Its location is typically near the accelerator pedal assembly, making it accessible for inspection and testing. With the correct voltage levels, the engine can respond appropriately to the driver's commands. Thus, any issues in this circuit can lead to poor engine performance or even stalling, making it critical to address this fault promptly. The error description for DTC P2127 highlights a problem with APP sensor B, which directly corresponds to the throttle position sensor E. The APP sensor sends voltage signals to the powertrain control module, PCM, allowing it to determine the throttle position. A low voltage condition means that the sensor is not providing adequate data to the PCM, which can disrupt the vehicle's performance. The APP sensor's location near the accelerator pedal makes it vulnerable to environmental factors and electrical issues. It is imperative to confirm whether the electrical connections are secure and if the sensor is functioning as it should. Diagnosing this issue correctly ensures that the vehicle operates at optimum performance. There are several possible causes for DTC P2127 that need to be evaluated. Firstly, a damaged APP sensor can produce erroneous readings or fail completely, leading to low voltage output. Secondly, faulty wiring, such as frayed or broken wires, can disrupt the signal from the sensor to the PCM. This fault may arise from wear and tear over time, or incorrect installation after repairs. Additionally, a bad connection at the PCM may lead to inadequate voltage levels from the APP sensor. Loose or corroded terminals may not provide the necessary electrical flow, triggering this code. Addressing these potential causes effectively will aid in the proper diagnosis and repair of the vehicle. The symptoms associated with DTC P2127 are crucial in identifying the issue with the APP sensor. Drivers may first notice the check engine light illuminating on the dashboard, indicating that the engine management system has detected a fault. Additionally, poor engine performance is often a notable symptom. The vehicle may hesitate to accelerate or may not respond appropriately to throttle input. Unresponsive throttle behavior can also occur when the APP sensor fails to relay accurate data, leading to a frustrating driving experience. These symptoms directly affect the vehicle's drivability, making early identification and troubleshooting essential to ensure the safety and reliability of the Honda Civic. The first troubleshooting step for DTC P2127 involves verifying the problem through a systematic approach. Begin by turning the vehicle ignition to the on mode, enabling the vehicle's electrical systems without starting the engine. Using the HDS Honda Diagnostics system, check the voltage parameters for the APP sensor B. Specifically, you need to confirm if the voltage reading is less than 0.2 V. This threshold indicates the presence of a fault, and if the results confirm that the current conditions match this threshold, it means the failure is duplicated. If the voltage reads correctly, the system may have intermittent issues. In such cases, it is advisable to inspect for poor connections or loose terminals at the APP sensor and the PCM, particularly if the onboard snapshot has recorded a fault. For the second troubleshooting step, you will focus on isolating the voltage supply to the APP sensor. Start by turning the vehicle to the off or lock position. Once the vehicle is off, disconnect the 6P connector from the APP sensor. This will enable you to specifically test the voltage being supplied without interference from the sensor itself. Next, turn the vehicle to the on mode again, ensuring all systems are powered. Measure the voltage between the designated test points at the sensor's 6P connector. You are looking for around 5.0 volt between these points, which is the standard operating voltage for the APP sensor. If this voltage is confirmed, you can proceed to the next troubleshooting step. If not, further investigation into possible open circuits or signal interruptions is necessary. In the third troubleshooting step, you will be checking for any shorted wires in the APS2 line that could be causing the low voltage condition. Begin by turning the vehicle to the off or lock mode. Initialize a short circuit simulation by jumping the SCS line using the HDS, ensuring you wait for over 1 minute for stabilization. Disconnect the PCM connector A, which has 50 pins, to isolate the circuit for testing. Ensure that any continuity between test points 1 and 2 is checked, where test point 1 is at APP sensor connector number 3, and test point 2 is to body ground. If continuity exists, it indicates that there is a short circuit between the PCM and the APP sensor, which will need to be repaired. However, if there is no continuity, it suggests that the APS2 wire is intact and further investigation is warranted. In step 4 of the troubleshooting process, you will perform an open wire check on the APS2 line to further isolate issues. Start by connecting terminals A and B with a jumper wire, where terminal A is the APP sensor 6P connector number 3, and terminal B is the body ground. This setup allows you to test for continuity effectively. Verify that continuity between test points 1 and 2, which includes the PCM connector A, number 34, and the body ground. If continuity is present, it verifies that the APS2 wire is functional, indicating that the issue lies elsewhere. Conversely, if continuity is absent, it suggests that there is an open circuit within the APS2 wire, necessitating repairs to restore proper function. The fifth troubleshooting step is a critical check for the PCM's internal circuit functions. Begin by removing the jumper wire from the APP sensor 6P connector and reconnecting the PCM connector A, which has 50 pins. Next, you will set up a test by connecting terminals A and B, where terminal A is at APP sensor connector number 1 and terminal B is at APP sensor connector number 3. Turn the vehicle ignition to the on mode and employ the HDS to check the voltage at APP sensor B. You are checking for values that should be below 0.2 volts, confirming that the circuit is functioning correctly. If the conditions match, you will then consult authorized service information to assess the DTCs or symptoms you are troubleshooting. It is also prudent to substitute a known good PCM and see if the DTC P2127 clears. If it does, then replacing the original PCM is recommended. In the sixth troubleshooting step, the focus shifts to checking the integrity of the VCC5 line, which is crucial for the appropriate functioning of the APP sensor. Begin by turning the vehicle to the off or lock mode. Similar to previous steps, establish a temporary short by jumping the SCS line using the HDS, ensuring to wait for more than 1 minute. Disconnect the PCM connector A, 50P, to isolate the circuit from the PCM. Next, connect terminals A and B, where terminal A is at APP sensor 6P connector number 1, and terminal B is to the body ground. This configuration will help verify continuity between the specified test points, which will include PCM connector A, pin 44, and body ground. If you find continuity here, that indicates the VCC5 wire is functioning properly. If continuity is absent, it necessitates immediate repair of any open circuits within the VCC5 wire, leading back to the APP sensor. The final repair verification stage is crucial to ensure all repairs have effectively resolved the issues related to DTC P2127. After all troubleshooting steps have been conducted and necessary repairs completed, it is vital to recheck the vehicle's performance. Start by confirming that the check engine light has cleared and no new DTCs have surfaced. It is advisable to conduct a test drive under various driving conditions to ensure the vehicle functions correctly without any signs of disturbance. Monitor the accelerator pedal's responsiveness closely to ascertain that no further issues arise. If DTC P2127 remains cleared and drivability has improved, it signals that the repairs have been successful. Documentation of these checks ensures a complete service history for future reference. Preventive maintenance is an important aspect of vehicle care that can mitigate future issues related to DTC P2127. It is crucial to routinely check the electrical connections around the APP sensor and PCM, ensuring that they remain tight and free from corrosion. Inspections of the APP sensor itself should also be part of regular maintenance, as wear and tear can lead to malfunctions that trigger error codes. Keeping wiring intact and free from abrasion or damage is essential to prevent shorts or open circuits. Regular diagnostic scans can help identify issues before they develop into serious problems. Implementing these preventive measures ensures the continued optimal performance of the Honda Civic. In conclusion, DTC P2127 signifies a critical issue with the APP sensor B due to low voltage conditions, impacting vehicle performance. Understanding the role of the APP sensor and the consequences of low voltage readings allows for effective troubleshooting. Following the diagnostic steps closely, from verification of the fault to continuity and voltage checks, ensures that the issue is accurately identified and resolved. Regular preventive maintenance and inspections can also significantly reduce the likelihood of encountering similar code triggers in the future. Emphasizing these key points will help maintain the overall performance and reliability of Honda Civic models from 2016 to 2021. Please like and subscribe to the channel. See you next time.